I feel like with our previous problems, this bullet's going to be traveling at like Mach 98.
Yeah.
So here we have a bullet.
Like 900 million
I have a
miles.
little handgun here.
We have a car that can do Mach 14.
Little handgun. And so the bullet is going upwards.
Flare gun.
Straight upwards. So I'll give it several velocity vectors slowing down. Just like tossing the ball upwards. And then it'll turn around and go back down. Alright.
Finals we go.
All I want to know is, given the initial velocity of the bullet, 101 meters per second is the initial velocity right out of the chamber. I want to know the maximum height. Alright, so before work ahead of me, even though you haven't seen one of these worked, I think you know enough from free fall and from cars accelerating down the road to work this. So let's give yourself the big five, X, B, V sub O, A, and T. Work your way down the list until you know what equation it is that you'll use. When you have a conjecture on what equation to use, flag me down and point to the equation, write it down, and let me see if it's the correct one. And I'll give you the okay to finish. So you're working toward the equation. Adam, there's a dramatic pause here.
Pausing for a brief intermission.
Got one yet? Which equation? Alright, go on with that.
That HT stands for height, right?
It does. Find height. In our equation, height shows up. In our equation, height shows up as x, a displacement. So make sure you have x in your equation. It is what we're looking for. Alright? Do you know what equation? Which one? Yep. Onward. Go ahead and actually put the values in and find the maximum height. V squared. Very good. Because this problem is for maximum height, we can cut the problem off at maximum height. So let's start the problem here and end the problem here. So I'm cutting the problem in half. And I'm just using the yellows on the right. I'm sorry, on the left, the yellow arrows. So at the end of this problem, velocity final is going to be 0. I mean, velocity final, which we call V, is 0. Do you see why? Because at the end of the whole thing, the whole process, the bullet returns to where it started, and it's 101. But we're not interested in that half of the problem. In this problem, maximum height occurs right here. So I'm going to stop the problem there, halfway through, and start it here, stop. So therefore, velocity final will be 0. That is one trick of our maximum throwing upward problems. Cutting the problem in half, so final velocity is 0. Kevin?
Is velocity initial 0 as well?
No, because it came out of the chamber with this.
Okay.
So this is velocity 0 right there. Velocity final.
Okay.
So it's the opposite of dropping something.
Okay.
Acceleration is? Acceleration, because we're in free fall. Well, it's a vertical problem like this, so the only acceleration is due to good old planet Earth, and it's those numbers, negative 9.8 and negative 32. Since we're working in meters, it'll be acceleration. Pardon? It still doesn't matter. The Earth, even though it's going up, the Earth is still accelerating it downward. That's what's making it go slower. So acceleration is still downward. Negative 9.8. Final. I did not get that. Did you square the 101?
Yes, ma'am.
And you used negative 9.8.
Yeah, man.
Maybe I got it wrong. Let me see what others got.
That's
Yeah, that's what I got. And two sig figs. All right.
Oh, no.
Is that a mistake?
I was divided by 2. I didn't want to.
Okay. All right.
Do you hear that, Adam?
All right.
About 20.46.
All right. So how's it coming?
Oh, I don't know if this is right. But this is,
Oh.
This is what I got. Is that right?
Yes, except
Yay.
for 2 sig figs and
Two-
units are meters.
Only 2 sig figs.
Yeah, because that 9.8, the pesky 9.8.
Little booger.
I gotta find out what the next digit is, so then we
Bless
can be
you.
more precise in our answers.
So is it, okay, so 2 sig figs, so
Yep.
that one?
There you
Yay!
go.
Here's 20.
Alright. Here's what I have seen. I have seen,
520.
using the second equation,
You
I
were
have
there for
seen
20
0 equals 101 squared plus 2 negative 9.8 x.
Hey, I mean, there we
All right.
go, okay.
Your last, you have to square this, move it over where it becomes negative, and divide by that.
Square what? You got 520, right?
We don't have theology.
Alright, are you on board, Jonathan?
Yes, ma'am. I
How
got it.
about Dimitri?
Oh,
Did
yeah,
it
yeah,
work now?
Yeah.
Kevin?
I got it.
Alright. Drew? Alright, I saw the others. Alright.
Me.
Alright, this time, we'd like to add complications to our scenarios.
Welcome to physics.
So another complication. Is it 15 minutes?
Not yet.
Alright. So we have a cliff. So first, this is a cliffhanger problem. So go ahead and draw a person on the very edge of a cliff.
Oh dear.
Same.
And they're throwing an object upwards.
He's the same guy.
The gun didn't work.
The object goes upwards. So it has an initial velocity.
Hey, you wanna go play ball on the edge of the cliff?
As discussed before, it's going to slow down.
Oh, he
So
was going
sketch
up.
this. Sketch this
Up.
cliffhanger example. Then after it slows down to a stop,
Drew an
it's going to
upside down
reverse.
Minnesota.
But the complication is it can go past where it started. So this is a complication. Your friendly kinematic equations know all about it though. So you're going to do it exactly the same way. So the question is, let me put in some details. The velocity initially out of the hand is
300 miles an
2.3
hour.
meters per second. And I want you to find where it is after 0.60 seconds. Find where it is after 0.6 seconds. So when I'm asking for where it is, what variable are we looking for? John? Where? What variable would that be in our list?
Can you just zoom in on that one?
Which one? Yes, so we're looking for position or displacement, so we're looking for x. In this scenario,